Hello everyone, welcome to Math Archives. This is Subhashini Vijaysekharan, a maths teacher. In this video, we have to see how to calculate median. The median refers to the middle value in a distribution. That is, median is the value that splits the entire set of data into two equal parts. That is, in short, median is the middlemost observation where we have 50% of the item before it and 50% of the item after it. That means it divides the entire set into two equal parts. That's why median is also known as positional average. Positional average. Because the value of median always depends upon the position of an observation, not on its magnitude. That's why it is also known as positional average. Based on the position, median gives us the value. So, median of a distribution is the value of a variate which divides it into two equal parts. Now let's see how to calculate median for integer series, discrete series or ungrouped frequency distribution, continuous series or grouped frequency distribution. Let's now first discuss about how to calculate median for integer series. For that, first you have to arrange the data in ascending or descending order of its magnitude. Ascending or descending order of magnitude, both of them gives you the same answer. But it's more convenient for us to arrange them in ascending order. So, in the forthcoming examples, I have to arrange all the data in ascending order. Then, we make use of the formula after arranging the data in ascending or descending order of its magnitude. Median is equal to size of n plus 1 over 2th item. Here, capital N represents number of items given in a data set. That is, how many number of items are given. So, based on that, we are having one more questions. That means the number of items may be either even or odd. Suppose when the number of observations is even, then median is the average of the two middlemost observation. On the other hand, when the number of observation is odd, then the median is the middlemost observation. In both the case, first you have to arrange the given set of data in ascending or descending order of magnitude. You just keep this point in mind and let's now move on to an example. Determine the median. The set of values are given. So, the values are neither arranged in ascending or descending order of its magnitude. So, for that, first you have to arrange the given set of data in ascending order. Values in ascending order first. I have to arrange them. Values in ascending order. Let's start with the least value. Here 7 is the least value. So 7, then 10, then 12, then 15, then 18, then 20, then 25, then 45, 38. and then the last value 45. Here totally we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So here n is equal to 9. Capital N is equal to 9. So now we make use of the formula. After arranging them into ascending order, we make use of the formula median is equal to size of n plus 1 over 2th item. That is size of capital N is 9. That is totally we have 9 items given in this data set. 9 plus 1 over 2th item. While we add 9 with 1, we have size of 10 over 2 the item. That is size of, while we dividing 10 by 2, we have 5, 5th item. That is value at the 5th position gives you the median in this case. In the 5th position we have 1, 2, 3, 4, 5. In the 5th position we have the value 18. So median is equal to 18. Let's move on to another example. Determine median. Here itself the values are given that are neither arranged in ascending or descending order of magnitude. So we have to arrange the given set of data in ascending order. So values in ascending order. Seven is the least value. So start with 7. Then we have 10. Then we have 12. Then we have 15 and 18. 15, 18. Then we have 20. Then we have 25. Then we have 38. Then next 45. And then 64. So now we have arranged the given set of data in ascending order of its magnitude. Let's count how many number of items are given here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here n is equal to 10. That is 10 items are given. So now we make use of the formula median is equal to size of n plus 1 over 2th item. That is size of capital N is 10. So 10 plus 1 over 2th item. That is size of, while we add 10 with 1, we have 11. 11 over 2th item. While we divide 11 by 2, we have just manual calculation is enough here. So 5.52 are 10. So 5.5. So here, look at here, the value at 5.5th position. 5.5th position gives you the median value. we have the values at 1, 2, 3, 4, 5. Fifth position we have 18, whereas the sixth position we have 20. And we doesn't have any value at 5.5th position. So for that, what you are going to do here is, you just add the value at 5th position and value at 6th position and then divide this by 2. So now I am going to add 18 plus 20 by 2. Since we don't have any value at 5.5th position, that's why I have to add the value at the 5th position and value at the 6th position and then divide this by 2 to get the median value. Adding 18 and 20, we have 38 over 2. While dividing 38 by 2, I have 1, 2, 2, remaining 1, totally 18, 9 2s are 18. So median is equal to 19 in this case. So now hope you got a clear idea about how to calculate median in case of individual observations are given. Let's now move on to how to calculate median in case of discrete series or ungrouped frequency distribution. So here we have to follow a set of procedures. So first point here is, you just arrange the given set of data in ascending or descending order of its magnitude. Then you have to calculate the cumulative frequency. Then you have to find out the median by applying the formula. Median is equal to size of n plus 1 over 2th item. Here n represents sum of frequencies, that is sigma f. Then you just find out the cumulative frequency just greater than or equal to the value of n plus 1 over 2th item. Then the corresponding value of x is the median. This is a set of procedures we have followed to calculate the median in case of ungrouped frequency distribution. Let's now move on to an example. Find the median. Here the income and number of persons are given. Now what you are going to do first is, first let us check whether the given set of data is in ascending order. 1000, 1500, yeah, and then 800. No, the given set of data is neither arranged in ascending order nor arranged in descending order. So let's first rearrange the given set of data in ascending order. For that, now let me assign the variable x for the income and f for the number of persons. So here x and f. Number of persons is represented by f and income is represented by the variable x. Here the least value, now I am going to arrange the given set of data in terms of ascending order of its magnitude. So 800 is the least value here. So let's start with 800. So 800 and its corresponding frequency is 16. So whenever you are going to arrange them in ascending order, so you have to list out the value of x along with the frequencies. Okay, 800. Then we have the next least value 1000. Corresponding frequency is 24. And then next we have 1500 and its corresponding frequency is 26. Next we have 1800 and its corresponding frequency is 30. Then we have 2000, corresponding frequency 20, and then 2500 and its corresponding frequency 6. So after arranging them in ascending order, then we have to find out the cumulative frequency and then we have to find out the value of n plus 1 over 2. For that, now let's construct a table. whereas the first column consists of x. The second column consists of f. And third column represents cumulative frequency. That is represented as CF here. As I told you already, you have to assign the variable x for income and number of person as f. So the least value first is 800. Corresponding frequency 16. Then 1000. Its corresponding frequency 24, then 1500, corresponding frequency 26, then 1800, its corresponding frequency is 30, then 2000, corresponding frequency is 20, the last 2500 and its corresponding frequency is 6. Now let's calculate the cumulative frequency. Cumulative frequency is calculated by adding each frequency in a frequency distribution to the sum of its preceding frequencies. So for the first one, we have 16. 16 doesn't have any preceding frequency. You just write 16 here as it is. Then for the next one, 24 having the preceding frequency 16. 24 has the preceding frequency 16. So now you have to add 24 with 16. While we add 24 with 16, we have 40. Then for the next one, 26 has the preceding frequencies 24 and 16. So now you have to add 24, 16 and 26. You have to add the three values. While we are adding all these values, we get 16 plus 24 plus 26 gives you the total as 66. And for the next one, 30 has the preceding frequencies 26, 24 and 16. So now what I am going to do here is, instead of adding with these three frequencies, I have to, because already we have the addition of these three frequencies as 66. So I have to add this 30 with 66. Is it right? Listen one more time. Here the 30 has the preceding frequencies 26, 24, 16. So I have to add 30 with these three frequencies. So instead of doing like that, I just directly add 30 with 66. So while we add 30 with 66, we have 96. And then 20 has the preceding frequencies of 30, 26, 24 and 16. For that, I have to directly add the addition of these three frequencies 96. So now I have to add 96 with 20. So you get the value 116. Then 6 has the preceding frequencies. These are the preceding frequencies of 6. So instead of adding this once again, I have to directly just add 116 with 6. That gives me the total as 122. Now we calculated the cumulative frequencies. What we are going to do now is, let's now calculate the value of n. N is nothing but sigma f. That is sum of all frequencies. Now adding all values of f, that is 16, 24, 26, 30, 20 and 6, we have 16 plus 24 plus 26 plus 30 plus 20 plus 6. We have a total of 122. Look at here, the last value of CF is nothing but Rn value. Always these two values will coincide, that is, will be the same value. So here likewise you have to check whether the calculated value of F or CF is right. Now let's now move on to the calculation part. After calculating the cumulative frequencies, now we make use of the formula median is equal to size of n plus 1 over 2th item. That is, here capital N represents sigma f. That is, size of capital N value is 122. So 122 plus 1 over 2th item. While we are adding 122 with 1, we have 123 over 2. While we divide 123, that is, while we add 122 plus 1, we have the total 123, and we divide this by 2, we get 61.5. So that is equal to size of 61.5th item. So median is equal to size of 61.5th position item gives you the value of median. Now we have to find the cumulative frequency which is just greater than 61.5. This is the first frequency, 16, 40, 66. Yes, this is the frequency which is just greater than 61.5. That is the nearest frequency for 61.5 is 66. So the cumulative frequency just greater than 61.5 is 66. And the corresponding value of x is the median. Corresponding value of x is the median. The corresponding value of x here is 1500. So the corresponding value of x is 1500. So median is equal to 1500. So hope you got an idea about how to calculate median for ungrouped frequency distribution. Let's now move on to how to calculate median for continuous series or grouped frequency distribution. For that, first we have to find out the median class. That is the class corresponding to cumulative frequency just greater than or equal to n by 2 is called the median class. After finding the median class, we make use of the formula median is equal to L plus H by F n by 2 minus CF. Here L represents the lower limit of the median class, F represents the frequency of median class, H represents size of the median class, and CF is cumulative frequency of the class preceding the median class. Also, you just have a point to keep in your mind that this formula is used only when the class intervals are this formula is used only when the class intervals are continuous and ascending order. Only when we have to use this formula to calculate the median for in case of grouped frequency distribution. The class intervals are continuous means there is no gap between one class interval to another class interval. Suppose if there is a gap, you just convert them into a continuous class interval and then you have to proceed by using the formula to calculate the median. Then the class intervals are always arranged in ascending order. So if it is in terms of descending order, so you have to first arrange them in ascending order of its magnitude and then you have to proceed. So this formula is used only when the class intervals are continuous and ascending order. Let's now move on to an example. Find the median of the following. Here the marks and number of students are given. Both of the marks are given here in terms of intervals, that is class intervals. So now let's check whether the class intervals are first continuous and ascending order. Here the class intervals are continuous. That means there is no gap between one class interval to another class interval. So for the first and second class interval, the lower limit of this class interval is the upper limit of the next class interval. So there is no gap. Here itself, the lower limit of the second class interval is the upper limit of the third class interval. Here itself there is no gap. Like that for the next and the last one too. So here the class intervals are continuous. So class intervals are continuous in this case. And then next, let us check whether they are arranged in ascending order or not. Here the order of arrangement are in ascending order. So the class intervals are continuous and also in ascending order. So now we make use of the formula median is equal to L plus H by F into N by 2 minus CF. So to use this formula, let's find out what is the median class. After finding the median class only, then we make use of this formula to get the median value. For that, let's now construct a table, whereas the first column represents marks, the second column represents number of students, and third column is nothing but our cumulative frequency. Now I have to assign the variable x for marks and f for number of students. Let we assign the marks as the variable x and number of students as the frequency. Here the marks are given in terms of class intervals. So 20 to 30, corresponding frequency 3, 30 to 40 and its corresponding frequency 5, 40 to 50 and its corresponding frequency 20, 50 to 60 and its corresponding frequency 10, and 60 to 70 and its corresponding frequency is 5. Now let's first calculate the cumulative frequency. As usual, first write down 3 as it is because it doesn't have any preceding frequencies. Now we have to add 5 with 3. If we add 5 with 3, we have 8. Then instead of adding 5 with 3 with 20, I am just directly add 20 with 8 because 8 is the total of 3 and 5. So 20 with 8, that is 28. Then 10 has the preceding frequencies 3, 5, 20. So already I have calculated the addition of these three values as 28. So I just directly add 28 with 10, that is 38. And 5 has the preceding frequencies 10, 20, 5 and 3. Already I have a total of these values as 38. So I just directly add 38 with 5. So 38 plus 5 is 43. So the calculation of cumulative frequency is over. Now we calculate the value of n, that is sum of the frequencies. While we add all the values, we get 5 plus 3, 8, 8 plus 20, 28, 30, 8 plus 5, 43. So let us now here cross check the value of n with the last value of CF. Both of them are same. So that means there is no mistake we have committed while adding the values of F and CF. Now what we are going to do is, let's now calculate the value of n by 2. To find the median class first. That is, what is the median class interval? That is first we have to find out to apply this formula. So n is nothing but 43 over 2. While we divide 43 by 2, we have, when we divide 43 by 2, we have 21.5. 21.5. Now we have to find out the cumulative frequency just greater than or equal to 21.5. That is, cumulative frequency just greater than 21.5 is cumulative frequency just greater than 21.5 is 28. That is, 28 is the nearest frequency to 21.5. So this is the median class. That is 40 to 50. That is cumulative frequency just greater than 21.5 is 28. Therefore, our median class is 40 to 50. So this is our median class. Now let's make use of the formula to calculate the median. For that, here we need the values of L. That is, median is equal to L plus H by F n by 2 minus CF. Here L is nothing but lower limit of the median class. So this is the median class. Here the lower limit is 40 is the lower limit, 50 is the upper limit. So L is 40. H. H is nothing but size. Size of the median class. Look at here. All the class intervals are of size 10. That is a 10 gap between one class interval to, that is one upper limit. That is the difference between both upper limit and lower limit of the class interval is 10. That is nothing but a size of the class interval. So H is equal to 10. F represents frequency of the median class. Here 40 to 50 is my median class interval and its corresponding frequency is 20. So F is the frequency of the median class interval. Then next, already I know the value of n by 2. So that is 21.5. And then CF. CF is cumulative frequency of the median class preceding the median class. So this is my cumulative frequency of the median class, but CF is the cumulative frequency of the median class preceding the median class. So instead of writing 28, I have to take 8 because 8 CF is equal to 8. So now we make use of all the values in the formula to get the value of median. Now L is 40 and H is 10 and its corresponding frequency is 20. and n by 2 is 21.5, CF is 80. That is 40 plus 10 over 20. While we subtracting 21.5 minus 8, we have minus 8 gives you the value 13.5. Then you multiply 13.5 with 10 into 10. We have 135 and we divide over 20. Then we have to divide 135 by 20. We have 6.75. And we add this with 40. We have 46.75. So median is equal to 46.75. Always median of any value lies within the median class. Here our median class is 40 to 50 is our median class. 40 to 50 is our median class. So the value of median always lies within the class interval. So 46.75 lies within the class interval 40 to 50. So our calculated value is correct. This is how you have to check whether the calculated value of median is correct or not. So with this, hope you got a clear idea about how to calculate median in case of individual series, ungrouped and grouped frequency distribution. Thanks for watching. See you again in my next video.